Hello students, already I have explained chapter light in my previous videos, and today I am going to discuss about some numerical problems based on mirror formula and lens formula. Now first of all, I am going to show some numerical problems based on spherical mirror. Now we know in case of a spherical mirror, mirror formula is 1 by V plus 1 by U equals to 1 by F, where V is the image distance, U is the object distance and F is the focal length. Magnification in case of a spherical mirror is the ratio of height of the image by height of the object, or we can say minus image distance by object distance, which we can say magnification equals to hi by h naught equals to minus v by u. Based on these two formula, we are going to do sums of spherical mirrors. Now I am going to show one numerical problem based on concave mirror. Here question is, an object 3 cm high produces a real image 4.5 cm high. When placed at a distance of 20 cm from a concave mirror, calculate the position of image, focal length of the concave mirror. As given in the question, an object 3 cm high, so height of the object is 3 cm, produces a real image 4.5 cm high. That means height of the image will be minus 4.5. Since image is real, so it will be minus 4.5. When placed at a distance of 20 cm, so object distance is always negative, and here it is 20 cm. We have to find the position of the image and the focal length. Now here height of the object is 3 and height of the image is 4.5. That means image is magnified and image is real. This is possible only when object is between C and F. If object is between C and F, any ray which is parallel to the principal axis, after reflection, it will pass through the focus. Another ray which passes through the focus, after reflection, it becomes parallel to the principal axis, and these two rays are going to meet here, so image will form here. This is the object whose height is 3 cm. Height of the image is 4.5. As you can see here, the image is magnified and it is real image. Reflected rays are real emitting, so image is real. And since real images are formed below principal axis, so this will be minus 4.5. Since it is below principal axis, that's why we have to give this negative sign. This is the object. It is in the left hand side of the pole, so object distance is negative. We have to find the image distance, that means this distance we have to calculate, and the focal length of the concave mirror. In case of spherical mirrors, we know height of the image by height of the object is minus v by u. Here height of the image is minus 4.5, height of the object is 3 equals to minus v, and u is minus 20. As given in the question, object distance is 20 cm. Now minus this 4.5 can be written as 45 by 10 by 3. Instead of 4.5, we are writing 45 by 10. Now this 45 and 3 can be cancelled, so we will get 15 here equals to v by 20. These two negative sign will cancel, so we are left with v by 20. So here we got minus 15 by 10 minus 15 by 10 equals to v by 20. This 15 and 10 can be cancelled by 5. 5 3 ja, 5 2 ja. So if we cross multiply, twice of v equals to minus 3 into 20 minus 60. So v equal to minus 60 by 2. So v we got minus 30. Since v, which is the image distance, is minus 30, that means image is formed at a distance of 30 cm in front of the concave mirror. Here also in this figure you can see this is the image and this is the image distance. Suppose this is A, this one is B, this is A1, this is B1. So PB1 is the image distance. Since it is in the left hand side of pole, so image distance should be negative, and here also we got image distance is negative. Now we know mirror formula is 1 by V plus 1 by U equal to 1 by F. Okay, now 1 by V plus 1 by U equal to 1 by F is the mirror formula. Here U and V are known, but F is not known. So instead of V, you can write minus 30 because we got V equals to minus 30. u given in the question minus 20 equals to 1 by f. So we can write minus 1 by 30 plus minus 1 by 20 equals to 1 by f. Here LCM will be 60. 60 divided by 30, it will be 2. 2 into 1 minus 2 minus 60 divided by 20, it will be 3. 3 1 ja 3 equal to 1 by f. So minus 5 by 60 equal to 1 by f. So we got minus 5 by 60 equal to 1 by f. If you take the reciprocal of it, then f equals to minus 60 by 5. If I cancel, I am going to get 12. So f equal to minus 12 centimeter. That means focal length of the concave mirror is minus 12. In case of a concave mirror, focal length is negative. So after calculation also we must get negative. I hope the sum is clear. Let me discuss another sum. Let me discuss one sum from convex mirror. Here question is, an object 5 centimeter high forms a virtual image of 1.25 centimeter high when placed in front of a convex mirror at a distance of 24 centimeter. Calculate the position of the image and the focal length of the convex mirror. As given in the question, an object 5 centimeter high, suppose this is the object which is 5 centimeter high. Suppose this is AB. An object 5 centimeter high forms a virtual image of 1.25 centimeter high. So since this is the object, this is one convex mirror. Suppose this is center of curvature and this is the focus. This point is pole. We know any ray which is parallel to the principal axis, after reflection from a convex mirror appears to come from focus. So this will appear as if it is coming from F. Another ray which is in the direction of C, any ray which is in the direction of C, after reflection it will move in the opposite direction. So this will reflect this way. So these two rays appears to meet at this point. So image of A will be formed here and image of AB will be formed here. This image is virtual, so we have given dotted line. Let it be A1, B1. Now as given in the question, an object 5 centimeter high forms a virtual image of 1.25 centimeter high when placed in front of a convex mirror at a distance of 24 centimeter. That means this distance is 24. This is 24 centimeter. We have to find the distance of the image and the focal length of the convex mirror. Here height of the object is 5 centimeter and just because it is above principal axis it will be positive. So height of the object is 5 centimeter. Here image, this is also above principal axis, so this also will be positive. It will be 1.25 centimeter. Here AB is the object, so object distance is PB. Since object is in the left hand side of pole, so object distance will be negative. So U is minus 24 centimeter. We have to find the image distance. This is the image. So this distance we have to calculate and the focal length. In case of a spherical mirror, we know the magnification formula is Hi by H0 is minus V by U. This formula is applicable both for convex and concave mirror. Now here height of the image is 1.25 centimeter. Height of the object is 5 centimeter equals to minus V. U is minus 24. Now 1.25, this can be written as 125 by 100 because after decimal there are two places. We can write 125 by 100 into 5 equals to V by 24. Now 5 and 125 can be cancelled. We got 25. So here we got 25 by 100 equal to V by 24. This 25 and 100, if we cancel by 25, here it will be 1, it will be 4. So 4V equals to 24. So V equal to 24 by 4. That means V equal to 6 centimeter. Here V is positive. That means image is formed at a distance of 6 centimeter behind the mirror. Since it is positive, it must be in the right hand side. And as you can see, this is the image. An image is formed in the right hand side. And here also we got positive. And as per the figure also it should be positive. So image distance is 6 centimeter. That means PB1 is 6 centimeter. We know mirror formula is 1 by V plus 1 by U equal to 1 by F. So 1 by V is 6 plus 1 by U is minus 24 equal to 1 by F. So 1 by 6 plus minus 1 by 24 equal to 1 by F. Here LCM of 6 and 24 will be 24. 24 divided by 6, it will be 4. 4 1 ja 4. Minus 24 divided by 24 is 1. 1 1 ja 1. 4 minus 1, 3 by 24. If I cancel by 3, 3 1 ja 3. 3 8 ja 24. So F equals to 8 centimeter. If you just take the reciprocal, F will be 8. Therefore, focal length of the convex mirror is 8 centimeter. And we know in case of a convex mirror, focal length is positive, and here we got 8 centimeter. Therefore, the image distance is 6 centimeter and focal length of the convex mirror is 8 centimeter. Though it is not mandatory to draw the figure, but if you can draw the figure, you can understand the sum in a better way. Now I am discussing this question, which is based on reflection of light. Here question is, the velocity of light in air is 3 into 10 to the power 8 meters per second, and in glass it is 2 into 10 to the power 8 meters per second. Find the refractive index of glass. Here velocity of light in air is given, velocity of light in glass is given. We have to find the refractive index of glass. As given in the question, velocity of light in air is 3 into 10 to the power 8 meters per second, and velocity of light in glass is 2 into 10 to the power 8 meters per second. We have to find the refractive index of glass with respect to air. Here light is moving from air to glass, so we will say refractive index of glass with respect to air. We know the formula that refractive index of glass with respect to air is velocity of light in air by velocity of light in glass. Now both the values are given in the question. Here it is 3 into 10 to the power 8 meters per second, 2 into 10 to the power 8 meters per second. Since refractive index is a ratio, we never write any unit. Here 10 to the power 8 will cancel, so we are left with 3 by 2, and 3 by 2 is 1.5. So refractive index of glass with respect to air is 1.5. Let me discuss another question of similar type. Here velocity of light in air is 3 into 10 to the power 8 meters per second. Calculate the velocity of light in diamond of refractive index 2.5. Here velocity of light in air is given. We have to calculate velocity of light in diamond, and it is given that refractive index of diamond with respect to air is 2.5. As given in question, velocity of light in air is 3 into 10 to the power 8 meters per second. Velocity of light in diamond we have to calculate, and it is given that refractive index of diamond with respect to air is 2.5. Refractive index of diamond with respect to air is 2.5. Now we know refractive index of diamond with respect to air can be written as velocity of light in air by velocity of light in diamond is equals to 2.5. Now velocity of light in air is 3 into 10 to the power 8 by velocity of light in diamond equals to 2.5. Now if we just interchange this, we are going to get velocity of light in diamond is 3 into 10 to the power 8 divided by 2.5. If I multiply both of them by 10, here it will be 3 becomes 30 and 2.5 becomes 25 into 10 to the power 8. Just to remove the decimal, we have multiplied both 3 and 2.5 by 10. We got 30 by 25. Now 30 by 25, if I cancel by 5, I am going to get 6 by 5 into 10 to the power 8 meters per second. And if I divide, I am going to get 1.2 into 10 to the power 8 meters per second. So this is the velocity of light in diamond. Next question is, a light of wavelength 600 nanometer in air enters in water of refractive index 4 by 3. Find speed, frequency and wavelength of light in glass. It is given that velocity of light in air is 3 into 10 to the power 8 meters per second. So here the wavelength of light in air is 600 nanometer. Nm means nanometer. Refractive index of water with respect to air is 4 by 3. We have to find the speed, frequency and wavelength of light in glass. Here wavelength of light in air is given 600 nanometer. Refractive index of glass with respect to air is given 4/3. And velocity of light in air is 3 into 10 to the power 8 meters per second. Now we know from the definition of refractive index that velocity of light in air by velocity of light in glass is the refractive index of glass with respect to air. Just imagine that this is glass, this is air. Ray of light is moving from air to glass. Okay, suppose this is the normal. So velocity of light in air by velocity of light in glass is termed as refractive index of glass with respect to air. Now velocity of light in air as given in the question 3 into 10 to the power 8. Velocity of light in glass is not known. This is 4/3 given in the question. So if I cross multiply 4 into velocity of light in glass equals to 3 into 10 to the power 8. So this 3 is multiplied with this and 4 is multiplied with velocity of light in glass. So velocity of light in glass, so 9 into 10 to the power 8 by 4. 9 divided by 4, it will be 2.25 into 10 to the power 8. So velocity of light in glass is 2.25 into 10 to the power 8 meters per second. The next thing that is required is the frequency. Now when ray of light moves from one medium to another medium, frequency of wave does not change. So frequency, whatever frequency is here, the frequency will remain unchanged. So we can write here frequency of wave does not change with the change in optical medium, hence remains the same. Clear? This is the second part. And third part, we have to find the wavelength of light in glass, and it is given that wavelength of light in air is 600 nanometer. Now we know this relation. In my previous video I have explained also that refractive index of glass with respect to air can be written as speed of light in air by speed of light in glass, which is equal to wavelength of light in air by wavelength of light in glass. Here refractive index of glass with respect to air is 4/3, which is equals to wavelength of light in air, it is 600 nanometer by wavelength of light in glass. This one we have to calculate. So if I cross multiply 4 into wavelength of light in glass equals to 3 into 600 nanometer. So wavelength of light in glass is 3 into 600 by 4. Directly also we can write after this step wavelength of light in glass equal to 600 into 3 by 4. Now 600 divided by 4, it is 150. 150 into 3, 450 nanometer. Therefore wavelength of light in glass is 450 nanometer. If you want, you can write this line here. I hope the sum is clear. Now I'll discuss a sum based on lens formula. Here the question is, an object when placed in front of a convex lens forms a real image of 0.5 magnification. If the distance of the image from the lens is 24 cm, calculate the focal length of the lens. As given in the question, the magnification is 0.5 and the image is real. So magnification symbol is M is minus 0.5, and it is given that if the distance of the image from the lens is 24, so image distance is 24 cm, and we have to find the focal length of the lens. So here magnification M is minus 0.5. We have given this minus because the image is real. Here image distance is given in the question 24 cm, and the focal length of the lens is to be calculated. But without knowing the object distance, we cannot calculate focal length. So first of all, we will calculate object distance. We know in case of a lens, magnification M equals to V by U. Here magnification is minus 0.5 equals to V by U. V is 24, U is not known. Minus 0.5 into U equals to 24. Now this can be written as minus 5 by 10 into U equals to 24. 5 and 10 can be cancelled, so it will be U by 2. So we can write here minus u equals to 24 to the 48. So u equals to minus 48 centimeters. Therefore object distance is minus 48 centimeter. Now since we know v and u, we can use lens formula to find the focal length of the lens. Now using lens formula we can write 1 by v minus 1 by u equals to 1 by f. This is lens formula. Okay, now v we know, v in the question it is given as 1 by 24 minus 1 by minus 48, as u is minus 48, equals to 1 by f. Now 1 by 24 minus minus plus 1 by 48 equals to 1 by f. Now LCM of 24 and 48 is 48. 48 divided by 24 is 2. 2 1 ja 2 plus 48 divided by 48 is 1. 1 1 ja 1 equals to 1 by f. So it will be 3 by 48 equals to 1 by f. Now 3 and 48 can be cancelled. 3 1 ja 3. 3 16 ja 48. Therefore f equals to 16 centimeter. Therefore focal length of the convex lens equals to 16 centimeter. Now I am doing a sum based on power of a lens. The question is, the focal length of a concave lens is 10 centimeter. Calculate its power. As given in the question, focal length of a concave lens is 10 centimeter. So here focal length, we can write the symbol f equals to 10 centimeter. Since the lens is concave, so focal length will be minus, okay, minus 10 centimeter. We have to express this one in meter. For this we have to divide by 100. So 10 by 100 meter. So we can write minus 1 by 10 meter. Now power of a lens formula is 1 by focal length in meter. Okay, this is the formula. Power of a lens is 1 by focal length in meter. Now here focal length is minus 1 by 10 meter. So 1 divided by minus 1 by 10. So it will be 1 divided by minus 1 by 10. So which can be written as 1 into 10 minus 10 by 1. That means minus 10 diopter. Therefore the power of the concave lens is minus 10 diopter. Let me do another sum based on power of a lens. Your question is, calculate the focal length of a lens of power minus 2.75 diopter. Here power is minus 2.75 diopter. Okay, and since it is negative, lens must be concave, because in case of a concave lens power is negative, and for convex lenses it is positive. Now we know power is 1 by focal length. So 1 by f equals to minus 2.75 can be written as 275 by 100. Now if I cancel 275 and 100 by 25, 25 4 ja 100, 25 1 ja 25, so it will be 11 by 4. So f equals to minus 4 by 11 meter. Okay, now if you want to convert in centimeter, we need to multiply this by 100, because 100 centimeter equal to 1 meter. So it will be minus 400 by 11 centimeter. Now if we divide 400 by 11, then we are going to get 36.36. Therefore minus 36.36 centimeter is the focal length of the lens. Another sum based on convex lens. A convex lens forms a real image magnified 4 times when the object is placed at a distance of 6 cm from the lens. Calculate the focal length of the lens. Now as given in the question, the image is magnified 4 times and it is real, so magnification is minus 4. Since it is real image, so you have to write minus, you just write real image here. And object is placed at a distance of 6 cm from the lens, so object distance, which is always negative, here it is 6 cm. We have to find the focal length of the lens. Okay, so focal length of a lens cannot be calculated without knowing u and v. Here v is not known, That means image distance is not known. So first of all we will calculate V, and after that we are going to calculate focal length of the lens. Now we know magnification of a lens is V by U. In case of mirror it is minus V by U, but in case of a lens magnification is V by U. Here magnification is minus 4 equals to V, U is minus 6. So if I cross multiply, I am going to get minus minus plus, 4 6 are 24. Therefore image distance is 24 centimeter. Now we know object distance, we know image distance, so we can use lens formula. Now lens formula is 1 by V minus 1 by U equals to 1 by F. Okay, here you can write lens formula. Now here V is 24, so 1 by 24 minus 1 by minus 6 equals to 1 by F. 1 by 24 minus minus plus 1 by 6 equals to 1 by F. LCM of 24 and 6 is 24. 24 divided by 24 is 1 plus 24 divided by 6 is 4. 4 1 are 4 equals to 1 by F. So 5 by 24 equals to 1 by F. Therefore F equals to 24 by 5. If you divide 24 by 5, you are going to get 4.8 centimeter. Therefore focal length of the lens, and since we got focal length positive, lens must be convex, so focal length of the lens equals to 4.8 centimeter. I hope you have understood the sum, and that's all for today. Thank you for watching.